Hi everyone, welcome back to the channel. It's Albert here. And today let's solve another challenging LeetCode weekly contest problem. The maximum number of non-overlapping subarrays with sum equals target. And I saw this is the question asked by Google, so let's take a closer look. First, let's go through the question. So given an array nums and an integer target, we have to return the maximum number of non-overlapping subarrays such that the sum of each subarray is equal to target. So for the first example, if each subarray can overlap, we will have total 1, 2, 3, 4 subarrays that their sum will equal to target 2. But since the problem specifies each subarray cannot overlap, so we will have only 2 overlapping subarrays, which is the first 2 element and the last 2 elements subarrays. And for the second example, there are totally 3 subarrays with sum equal to 6, which is 5, 1, 4, 2, and 3, 5, 1, 4, 2, negative 9. But we have to find the maximum number of non-overlapping subarrays. So we will pick the first 2 subarrays and output the result 2. And the key to solve this problem, usually for problems to calculate subarray sum, we will first think of prefix sum algorithm. And there's a very similar question, which is 560 subarray sum equals k. But for this problem, there are more constraints that we have to get the maximum numbers of subarrays, and each subarray cannot overlap. So the data structures and algorithms we have to use are 2 pointers, hash map, and prefix sum. And let me show you what I mean. So let's first take a look what is prefix sum. So prefix sum at each index in the array is basically the sum of all the items on the left of it. So for example, for this array 1, 2, 3, 4, 5, the prefix sum at index 0 is 1, at index 1 it is 3, which is 1 plus 2, and index 2 is 6, which is 3 plus 3, and so on. And prefix sum is very easy for us to calculate the subarray sum of any intervals in the array, which is basically the prefix sum right and minus the prefix left. So that means that if we want to calculate the subarray sum between index 2 and 3, which is 7, then what we need to do is take the prefix sum right, which is 10 at index 3, and minus prefix sum left at index 1, which is 3, and 10 minus 3 is 7, which is the subarray sum here. And with that in mind, let's see how to solve these questions. So first, we need to set up a few data structures and variables. And we will need a hash map here. The key is the prefix sum at every index, and the value is the index of the array. And then we will need a variable called complement, which is at each index, it is a prefix sum minus the input target. And finally, we will need a variable called right, which is the right bound of the subarray. For example 2 in a problem, first let's generate the hash map. The key is the prefix sum at each index, which is negative 1, 2, 7, and so on. The value will be the index of the array, so it will be just 0, 1, 2, 3. And then we go through the array and calculate the complement variable based on this formula. So it will be negative 7, negative 4, 1, 2. And once we found that the variable complement has already appeared in the hash map, then it means that the subarray between them, there's is sum which is 5 plus 1 in this case is equal to a target 6. Then we know that we have already found a subarray that the sum is equal to target. And the next thing we have to check that is if this subarray has overlap with other subarrays we have found. So to do that, we will need a variable right. It is initialized to -1. And then at index 3, we'll compare the value of the hash map at index 1, which is 1 and -1. And in this case, 1 is bigger than -1, which means that it is not overlapped with any other subarrays we have found. So here we will increment the result variable by 1. And then at index 3, we have to update the right bound to 3, which means that the right bound of the current subarray we have found is at 3. Okay, and then at index 5, we found another subarray that is sum is equal to target. And then we check that the value in the hash map is not bigger than right. So it means that it's another valid subarray. So we will increment the result by 1 here. And finally, at index 6, even the comp variable is -1, which already appeared in the hash map. The value of the hash map is 0. It is not bigger than the variable right, which is 5. So that means that that subarray will overlap with other subarrays we have found. So we won't add that into the result here. And because the question specifies that we have to get as many subarrays as possible, so that is why we have to update the right bound every time we have found a subarray to make each subarray as small as possible. Okay, and let's see the code. The code is actually pretty short and clean. So first, generate the hash map using the Python default dictionary, and then the first value, key value pair in the hash map will be 0 and -1, and then set up the variables we need, which is the results, the variable right, and prefix sum, and then use a for loop to go through the array and calculate the prefix sum on the go, and also the variable complement. So if complement is already in hash map, and also the value is equal or larger than right, then we know that we have found a valid non-overlapping subarray. Then we will increment the result by 1, and then update the variable right to a current index I. And on the go, we have to update the prefix sum and the index, the value index in the hash map. And for this example, at index 0, 1, 2, we will just update the hash map. The key is the prefix sum, the value is the index, and at index 3, the complement is in the hash map, and the value is larger than right. So we will increment the result by 1, and then we will update the variable right from -1 to 3. And the same at index 5, the variable complement is 8, already appear in the hash map, and the value is equals to 3 here. So we will increment the result by 1 and also update the variable right from 3 to 5. So the final result for this example is 2. And to review, so for problems need to calculate subarray sum, first try to think of prefix sum technique to solve this kind of problems. And the tricky part for this problem is we have to get the maximum number of subarrays, which means that we have to make each subarray as small as possible. So to do that, we will update the variable right, which is the right bound of each subarray once we found them. And the data structures and algorithm we use in this problem are 2 pointers, which is the right pointer, and the hash map, and also prefix sum. And time complexity of the solution is linear time, big O of n, and space complexity is linear 2, because we need to use the hash map to store the prefix sum and the index. Okay, and that will be all for today. I hope this video helped you to get a better idea of the solution and the data structure and algorithm we use behind this problem. So if you like this video, please give it a like and subscribe to my channel, and I will see you in the next time.